If I don't, even though I've recorded it, you're going to ask me to repeat it 100,000 times anyway, so I'm going to record it now. I have just received news about how your final exams are going to manifest themselves because they are different than what I have had previously been told. So, here is how it is going to work. In that final week, starting on starting on January 21st. All right. January 21st, you people are block D, yes? Yeah. Okay. So for me, on January 24th, you will come here at the very beginning of the day, 8:10 a.m. You will stay here till lunch. That is the day you will write your final exam for me. January 24th, in the morning, in this room. Do I make myself clear? Now, you also will have that exam for the government. Now, that exam for the government is on a rubric, 0 through 4. If you get 0, you don't graduate. Nobody in our building at all last year got 0. Okay? If you go to that exam, you read the question, you attempt every single question, meaning you leave nothing blank, you will get at least a 1 and you will pass. Do I make myself clear? Yes. That will happen in one of the afternoons of that week. I have not been given the schedule, so I cannot tell you when it will be. I do not know, so do not ask. I do know that you will be writing a final exam for me on January 24th. The afternoons of that week, the ones that are not scheduled for your numeracy exam, are yours to use how you see fit. What that means is if you have a missed test from me and you have not done the cumulative for it, or something like that, you could come into my room and do those things. Clear? Good. Glad everybody understands. Okay. Let us move on then. Cabbages. Yes, I know. We have to finish a little bit of notes from yesterday, and then we will carry on. Now, let us get to that and get it out of the way first. We ended up here. And we all were able to do A. So, A is taken care of. Here is B, down here. Which form should we use for B? The line of B is crossing the y-axis. So slope-intercept is not a great choice. Point slope. What's the first thing we should find?
The slope.
We should find either a point or a slope.
I did 1, 4. I did 4, 1. 4, negative 1. Negative 4, negative 1.
Right. Negative 4, negative 1 is Zach's first point. Then he would have done what? To where?
I would have gone to negative 2, negative 4.
Yes, negative 2, negative 4 right there. And then he would have found the slope. And what was the slope?
2, 4.
4.
I don't know, negative 2 plus
3.
I'm sorry, positive 2, negative 4. Holy crap, what is my brain?
That's 3.
I'll wait, because you're still not there.
Oh my god.
Up 3, left 2.
No.
3, minus 2. So the slope is negative 3 halves. And then you would put it in point slope form, which is y minus minus 1
Y plus 1.
negative 3 over 2 x minus minus 4. But we wouldn't write it that way because it's ugly.
Yeah.
Y plus 1 negative 3 halves x plus 4. Okay? That's B. What will we do for C?
Whoa. There's no slope.
There is no slope.
So it's 0.
No.
Nothing.
Is it like x? No.
X
X0?
equals
Like x equals 1.5.
X equals 5. Done. Some of you still have problems with that. I do not know why. What is the X value there? 5. What is it 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 there? There, 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 there. What is the X value always?
5.
5. So X equals 5. Because it can't equal anything else. What is D?
Y equals 9.
Y equals 9. Why? Because the Y value is 9. 9, 9, 9, 9, 9, 9, 9, 9, 9.
9.
Like the seagulls in Finding Nemo.
It's mine.
Except they're saying mine. If they were in a math class, they might be saying 9. Or if they were German, they might be
Yeah.
saying 9.
As no, right? Means
Yes. And lastly, E.
Y equals 2 over 7. Plus,
What are you going to use?
spine intercept.
You could use the slope intercept because it goes right there, yes? And the slope is,
2 over 7.
1 over
could I do that one? 1/3?
No.
Hey, you probably could.
I could. If you did that, would I give you full credit?
Yeah.
Of course I would. What could you do to make sure it's better?
Find a point.
Find further away points, just to make sure.
So
1, 2, 1, 2, 3, 4, 5, 6, 7. 2/7 is pretty darn close to 1/3, yeah? So I would be happy with that. Y equals 2/7 x minus, I believe that's 7. 6. Yeah? Okay. Everybody can now move about algebraic forms. You can go from algebra to graph. You can go from graph to algebra. Turn the page over. Now, this is not really a skill in which, in either graphing nor writing. This is more algebra practice. That question says I have to determine the value of k, yes? So if I were to move that k over there, would I have k equals something?
Yes.
What would I have?
K equals 3x plus 2y.
And we know from the previous 5 pages, there's an x, there's a y, and we know what to do with them, don't we? Every time we get a number that is written like this, where can those numbers go?
In an equation.
Into the equation. Agreed? Okay. Does that give me 2 numbers? It gives me 3, 0. That 3 is what?
Negative.
It's an x. That 0 is what? It's a y. And I know that 3 x's plus 2 y's will get me k. What goes in for x? 3. So what is that? 3 times 3 plus 2 times 0 equals k. So what is k? 9. Not a math skill. Practice for how we do this stuff. Algebra and substitution. What is the next one? What is my x and y there?
Negative
2,
0.
0. 3 times minus 2 plus 2 times 0. Do I need to even write 2 times 0?
No.
Of course not. Negative 6 equals k. Does everybody understand how it works?
Yes.
Great. Do the rest of the page. Go. Talk to your neighbor if you need to. Please remember that if you write out the ordered pair, you automatically have the x and y, which means it's really, really hard to do this wrong. You have to actually try to do this wrong. Keep working on E and F, ladies and gentlemen. I will be right with you.
Right, okay.
And what was E?
E is K equals 4.
And lastly,
Negative 6 equals K.
okay?
Yes. K.
All you're doing is substituting in. That's what the whole page is about. You get the x and y from this notation. You put the x and y where you see x's and y's. It's not complicated. The work tells you what to do. You learned in grade 9 that is x and y. You learned in grade 4 how to sub into equations. Put it together. Everybody good? Sweet. Now listen to me, because this is going to be a little confusing over the next couple of days. This stuff is not really graphing, and it's not really the next thing, which is why it's living by itself on its own little tab here. But it's not something I'm going to give you a test on, because it's not anything new. So that's why there is just an assignment for it. That assignment is due Friday. That's when we will mark it. All right? Today, we're going to start the last unit. Now, the first lesson of the last unit is all about graphing. What is your test on tomorrow? Graphing. So doing this right now works very well in that it ties in nicely with what we have just finished. Alrighty? Alrighty. Go to page 237, please. No. I changed it to Thursday because I was informed that Thursday is not a short day as I thought it was. I thought we would have double X blocks leading up to final exams. Silly me. Right? Why would we give you an extra hour to go where you need to get help with in the 2 weeks before a final exam? Right? but nobody asks me anything. And I foolishly assume that everybody else thinks the same way I do, which is obviously idiotic because I think sensibly, and other people don't seem to. So, because of that, I moved the test to Thursday, because I wanted to do this lesson to remind you about graphing one more time. Alrighty. So, again, you are not going to see anything new today. You are going to hear some new words. Much like almost all of grade 10, there has been very little new math, but new words and new applications of the old math. That's what's going to happen here. The first new word we have is, it's not a word, of course, it's a phrase, a system of equations. And a system of equations is very simply a group of at least two equations which may share a solution. Now, by putting the word may there, does it mean they will share a solution? Not necessarily. Everybody good? All right. So, now watch. Is that a system of equations?
Yes.
There's only one of them. It is not a system. Everybody good?
Yeah.
Does that equation have a solution?
Yes.
What is it? 6.
How do
By doing algebra. Minus 3 minus 3. X equals 6. Right? Okay. Ah! What the hell? Whatever. Now is it a system of equations?
Yes.
Do they share the same solution?
Yes.
Yes, they do. X equals 6. So now I have a system of equations that shares a solution because 6 will work with both of them. Do I still have a system of equations? Yes. Do I have a system of equations that shares a solution? No, because this guy is what? X equals 4. X is not the same, so even though it's a system, it does not, the whole system does not have a solution. Is everybody good?
Yeah.
Okay. Linear equations. We already know what a linear equation is. What is a linear equation? Y equals mx plus b is an example of a linear equation. Yes, excellent. Can anybody give me a definition of a linear equation?
An equation that includes x and y.
It needs to have x and y if it's going to be diagonal.
Right.
Now we're getting warmer. It's an equation that graphs as a straight line. All right, so a linear equation is an equation usually with how many variables? 3 variables?
2.
2 variables which graphs with a constant rate of change. Now, Ariana said that y equals mx plus b is a linear equation. Technically it is, but it's got 4 variables right now. So let's make this look like something we're more comfortable with. Y equals 3x minus 4. Everybody happy? 2 variables. If I put that on the graph, it's going to make a nice straight line. Yes? Does it have to be written that way?
No.
No, it could be in point slope form. Could be in general form. Could be in standard form. Right?
Yes.
So, now we know what a system is. We know what a linear equation is. What, therefore, is a linear system?
And a group of at least 2 equations.
a group of at least two linear equations which may share a solution. Everyone cool? All right, now, over here, please draw a coordinate grid. Anywhere on your coordinate grid, make a line with a positive slope. It doesn't matter where it is. Anywhere on your grid. Everybody draw a line with a positive slope. Mine is going to be red. Is everybody drawing a line? I bet some of you are lying, because I bet as soon as I draw this, I'm going to see pens moving.
I didn't.
Nice. Everybody cool? All right. Now, every single spot of the infinity of spots that is on that red line, spots is not the math word. What's the math word? Points. Every one of those points has coordinates, and those coordinates are written as what?
Equation.
X, Y. Now, when we do our work, we like to keep them as integers, right? 3, 2, 4, negative 7. But in reality, they can be any number, can't they? 3.175, 2.329, right? In reality. But for math purposes, we leave them as integers to make our lives easier, yes? Okay. We are aware that this is made up of x's and y's, correct?
Yeah.
All right. Now, if you have a different color, it would be good to use a different color. If you don't, it's no big deal. Make a slope with a negative... make a slope with a negative line. Make a line with a negative slope that crosses your positive slope. I know I just did it. You need to do the same thing. What is this line made up of?
Negative points. Well, negative,
No.
just points.
It is also made up of points, and every one of those points has what? A coordinate, x and y, correct?
Yeah.
What is special about that point?
It's the cross intercept.
That point right in the middle is an x and a y that is where? On both lines, right? The red line is y equals m, some slope, because we don't know what it is, x plus b, correct? The blue line is y equals negative m, because it's got a negative slope, we don't know what it is, x minus b. Notice, please, that since they are both linear equations, they have y's and x's. That point right there, which I use purple because it's a mix of blue and red, that point right there is an x and a y that will work in both equations. Does everybody understand?
Yeah.
Everybody. So, to solve a linear system means to find the... Now, in math class, it's always going to be x and y, yes?
Yeah.
But in reality,
It would be
it's the IV and the DV, isn't it? Right? Find the x and y values that work in the entire system. And please underline entire. Now, in grade 10, we only use linear systems. So we are only ever going to have lines. Clear? In grade 11 and beyond, you will be graphing things like this. A parabola. That parabola has an equation, just like every line has an equation. if I graph a second parabola, and that second parabola has an equation, how many solutions does that quadratic system have? 2, because the lines cross twice. Everybody understand? Easy peasy, right? Yeah. What would happen if one of those parabolas was sideways?
4.
Now there would be 4 solutions. Everybody clear? What if then along came a line? How many solutions does that system have?
6.
No.
4.
No. 2. Why is it 2, Gio? I don't know words.
I don't know. I can't find the words. Because they're together, they count as one or something.
That XY is on the blue line, the orange line, and the pink line. That XY is on the blue line, the orange line, and the pink line. Is that XY part of the pink solution?
No.
Is that one?
No.
So therefore they can't be solutions to the entire system. Is everybody good?
Yeah.
Now you don't have to worry about curves this year, but I want you to see what's coming. By showing you that the concept is no different, is it? The only problem with this is you don't know how to graph those curves yet. But if you could graph those curves, you already know how to graph a line, you could do the solution to a quadratic system. Everybody cool? All right. So, back to stuff that is actually happening right now. We are going to use graphing to solve this. Now, for our purposes, I am going to use only examples that we can put into slope-intercept form. Now, in reality, it could be any of our 4 forms, yes? But we're going to use slope-intercept form because I am not so interested in getting you to practice graphing now as I am getting you to realize that the answer is an x and y that works in 2 equations. Everybody with me? So they're always going to look like this. Remember, m is our slope, and b is our y-intercept. And just to remind you, y-intercepts are 0y in case we have to do some substituting later. And slope is rise over run. Yeah? So that's first step. Put them into those forms. Second step, graph each line. You put them on the graph. Third step, identify the x and y where the lines cross. Why does that work? Because those specific coordinates work in both lines. Is everybody good? Now, right now is usually when your brain should be filling up and you need to see it actually working, right? So let's make it actually work. I'm going to wait a second, make sure everybody's caught up, make sure most of the pens in their place have stopped moving. Allow time for anybody to ask a question if they need it. Okay, let's turn our page over. I'm going to use 2 different colors because it's easier for you guys to see if I use 2 different colors. I'm going to graph that guy in blue. I'm going to graph that guy in red. So, I have done this long enough that I could graph both of those without converting them. And without a table of values. But most of you probably would like to convert them, so we will do so. What will I do with this first one to make it easily graphable? You wanna? You could do that, or you could do like I said on the last page and put it into slope-intercept form by isolating y. So now I know I will go to 4 and I will have a slope of -1. Agreed?
Yes.
Now, I'm not going to put that on the graph right now. Why? What if I put that on the graph, positive 4, and I find that in the on the other line, I need a y of positive 12? Does that fit on the graph? No. So I don't want to go to the graph until I know the scales I need. Everybody cool? Or maybe the other line has a fraction. So I'm going to wait until I get the other line graphed. Or the other line set up to graph. 2y equals x plus 2. Y equals 1/2 x plus 1. Is everybody good? That's what you're about to be tested on tomorrow, so I sure hope everybody is fine. Let's graph it. Now, I see I don't have anything really special, so I'm going to go ahead and put it on the graph now. Okay, so my blue line goes where? Where should I go?
+4.
Up to +4. 1, 2, 3, 4. And what's my slope? -1. So however far down I go the same distance right. Everyone agree? So I'm going to go down 4, out 4, and I'm going to draw my line. Does anybody have a problem with what I have done so far? All of you should be able to do that pretty much in your sleep.
Why did you go to 4 on the x-axis?
Because it doesn't matter. Because I went 4 and 4. 4 divided by 4 is 1. I could have gone down 8 and write 8. Could I have gone down 77 and write 77? Yes. Could I have gone up 329 and left 329? Yes. Everybody good?
Yeah.
Okay. Now, where's the red line going?
You go to +1.
+1. And then what?
You
Up 1, right 2. And there's that line. What do you see right there?
up.
You see the coordinates of 2, 2. Those coordinates have an x and a y value. Now, here's where math teachers get incredibly frustrated. You've done all the work, right? This is the first time you've seen it in action. If I hadn't done this example for you and I told you, figure this out, you technically have the tools to do so, yes?
Yeah.
About half of you wouldn't bother. You would wait until I did it.
Yeah.
About half of the people that actually tried it would try it and say, I'm done. And about half of those people would say, well, walk up to me and say, did I do this right? Is there ever a need to do that in math class? No, of course not. Because of what reason? You can check everything. That's an X, right? What letter is that?
X.
X. So what can I write there? 2. That's a Y, right? What letter does that represent? Y. So what can I write there? 2. Is 2 plus 2 4?
Yes.
So it worked in that equation. What letter's that?
Y.
X. Negative. What can I write there? 2 plus 2. What letter's that? Y. So what can I put there? 2 equals 2. What is negative 2 plus 4? Is that 2? So it is right. Do you ever need to say, am I doing this right? No, because the answer tells you if you are doing it right. Are we clear? What if that x and y did not work in one of these? Do you have the right answer? No, which means one of your lines is graphed wrongly. Are we clear? Excellent. You guys try the second one. Talk Talk to your neighbor if you need to. This is not a test. And with no stress at all, because you're just learning, it's not a big deal. How many people have an answer right now? I am not asking if it is right or wrong. How many of you have an answer? What you think is the X and Y that works. Okay? Now that you have had enough time to do that, and you have what you think is the X and Y that works, is there a way to prove that you have the right answer? Have you done that? So, what is the right answer? 2 and negative 3. There it is. Is everybody good? It is exactly what we've done. Now, in the previous unit, you only ever had to graph one line. What's the difference now? You have to grab 2 lines. And then you have to use your grade 9 skills to tell me the coordinates of where those lines cross. I mean, really, I don't even need to give you a test on graphing, do I? I could just give you this test, and that would prove if you could graph, wouldn't it? Is everybody good? All right. Now, for number 3, you are seeing something new for almost all of you. If you are from another country, you may recognize that notation. But most of you Canadian kids will not have seen that. But the reason it's here is not to stress you out. It is not here to show you, to make you worried. It is there to show you that no matter what, if you know how to graph the equations, you can always find the solutions. Okay? So, let's talk about what this means for 1 second. You do not need to commit it to memory. I just want to talk about it. Those are what are called absolute value brackets. What they mean is they are not counting a direction of the number. What are the 2 directions that all numbers have? Positive and negative, right? If I say, put a dot at positive 3, where do you go? I go to the right of 0. 3. If I say put a dot at negative 3, where do you go? Negative 3, to the left. How far did you travel in both cases? 3. That is absolute value. The absolute value of 3 is 3, because you went 3 steps away from 0. The absolute value of negative 3 is 3, because you went 3 steps away from 0. Everybody cool? So what would the absolute value of negative 16 be? 16. What would be the absolute value of 16?
It's negative 6.
No. It's 16. It's just a distance. Right? Back to magnitude and vectors, right? Okay. So, now that you know that, let's look at this. Y equals the absolute value of x. If there were no brackets there, no absolute value brackets, could you graph that? Sure you could. Y equals x. No matter what you say for x, y is the same, right? So if x is 0, what's y? 0. When x is 0, y is 0. When x is 1, what's y? 1. When x is 2, what's y? When x is negative 2, what's y? No, I don't have the values there. It would be negative 2, correct? But those lines are there, so what does this become? Positive 2. What if it was negative 3? What would this be? Positive 3. So now I have a bunch of coordinates I could graph it, right? So I'm going to go ahead, I'm going to put it on the graph. And like I say, this isn't to stress you out. This is just to show you something that will be helpful later on. So I know that my blue line is going to go up there, right? And then when x is negative 2, y is positive 2. So it's going to go like that. Everybody cool? It makes a V. Because I can never have an output of negative because of the absolute value symbols. Everybody cool? Easy peasy, right? Okay. Now, that, how do I graph that one?
You go to positive 3.
1, 2, 3.
Go up 1.
Up 1, out 2, and down 1 and left 2. And then I draw that line. Now again, this is the purpose of what I am doing here. What do you see? You see negative 2, 2.
They're the same.
And 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6. Because now I have two solutions. So now, because there's two intersections, how many xy's do I have to check? 2 of them. Is the absolute value of negative 2 positive 2? Yes. Is half of negative 2, which is negative 1, plus 3, positive 2? Yes. So 2, 2 works. Negative 2, 2 works. Is the absolute value of 6, 6? Yep. So 6, 6 works. What is half of 6? 3. Is 3 plus 3 6? So does 6, 6 work there? So I have my answer. Remember, this wasn't to stress you out. It was just to show you that even if it's something that looks different than two lines crossing, the answer will still be wherever those two lines touch. Toby. By making a table of values. Y equals x. When x is 0, what is the absolute value of 0? How far away is 0 from 0? 0. When it's 1 away, it's 1. When it's 2 away, it's 2. When it's negative 2 away, it's positive 2. When it's negative 3, it's positive 3. That gave me a bunch of dots. So I put them on the graph, and I connected them. Everybody cool? Yeah. Now, listen to me carefully. You have 3 choices for working right now. 1, you can work on that assignment that is due Friday. 2, You could work on the work that goes with this. It will help you practice graphing as well as get you going along on this unit. Or 3, you could simply review your graphing reviews and prepare for your test tomorrow. I do not care. It is your time. All right? Now, listen to me one more time. Number 8 and number 9 are very tricky and difficult to graph. If you could do them, you'd be in very good shape for your test tomorrow. Now, some of you really are uncomfortable sketching graphs, right? Like you have a lot of trouble telling me that that is 4, 3. 1, 2, 3, 4, 1, 2, 3. You have a lot of trouble with that. If you are that kind of kid, I have some graph paper right here. But please notice they are very little. So you may have to change the scales. Everybody with me? These will not help you with 8 and 9 unless you are very confident. Okay? You may need bigger graph paper to try 8 and 9. When will I be revisiting this? Friday. Because tomorrow you're writing your test on graphing. Everybody good? Everybody's got something to do? Go.